We are going to do a quick review of colligative properties. These are typical New York State chemistry regents questions, and let's start with the first one. We have standard pressure. We're looking at boiling point and freezing points, how they change when you are dealing with a solution of sodium chloride versus just good old water. Remember, pure water freezes at 0 degrees Celsius and it boils at 100 degrees Celsius. As soon as you have what's called a non-volatile solute, in other words, something that doesn't easily go into the gas phase itself, like a salt or a sugar, then just by having that solute present in the water, you are going to lower the freezing point and raise the boiling point. Freezing point depression, boiling point elevation. Salt dissolved in water, then we're going to get 100 plus degrees Celsius for a boiling point, and of course, we're in negative territory, less than 0 degrees Celsius for the freezing point. Both happen at the same time. The boiling point is higher for the salt solution and lower as far as the freezing point for the salt solution. So our answer here is choice D. Any solute that dissolves in water and is not volatile would have the same answer. The boiling point is elevated. In other words, it's going to be higher, and the freezing point is going to be lower. Let's look at another example. To what extent a boiling point would be raised and a freezing point would be dropped for water is two factors. One is what the solute is and how many particles it breaks up into, and the second is concentration. For potassium chloride, it's ionic, metal, nonmetal, it splits apart. You're going to get 2 moles of ions for every 1 mole of KCl. Calcium chloride, when this splits, you're going to get a total of 3 moles of ions for every 1 mole of calcium chloride. The calcium chloride, if this is 1 molar and this is 1 molar, the concentration is the same, so we're only looking at the number of particles, in this case ions, and calcium chloride is the winner. It is going to raise the boiling point and lower the freezing point more than the same concentration of KCl. So the freezing point is lower. In reading this question, the solute is the same for both solutions. NaCl. NaCl breaks up into 2 moles of ions for every 1 mole of NaCl. However, the concentrations are different. The more particles in solution, whether it's from the breaking apart into ions or concentration or both, the greater the effect. The higher the boiling point, the lower the freezing point. Compared to 0.1 molar, 0.8 molar of NaCl is going to have a higher boiling point and a lower freezing point. Let's take a look at one more question where we have different solutes and different concentrations. This question is going to take a little bit more to process, but following along, I promise you it will make sense. We want to go from highest boiling point to lowest boiling point. We have to take a look at concentration and what the actual solute is. We know that water boils at 100 degrees Celsius. However, when we have a solute dissolved in water, we're raising the boiling point. Our highest boiling point is going to have the solute that breaks apart into pieces along with concentration. Before we get to concentration, let's look at our solutes. Barium chloride, when it splits, there's the ionic bond. We're going to get 3 moles of ions for every 1 barium chloride. Sodium nitrate splits at the poly. Sodium ions and the nitrate ions, we're getting 2 moles of ion. Glucose is a sugar. Sugars are soluble in water, but they do not split up into ions. There are no ionic bonds in those molecules. So for every mole of glucose, I'm getting 1 mole of particles. And for potassium sulfite, K2SO3, it's splitting at the poly. I'm getting a total of 2 plus 1 or 3 moles of ions. If you forgot your polyatomics, remember, if you're using the New York State reference tables, there is a table there. It's splitting where the ionic bond is. The polyatomic does not split apart, that stays together. All right, now we have to also take into account concentration, and it's a multiplying effect. We have 3 here with barium chloride times 2, so that's a factor of 6. That would get multiplied with the constant that has to do with the boiling point of water. If you're in a New York State Regents class, you're not responsible for the end result as far as the new boiling point, but know the factor is 6. For letter B, it's 2 for the splitting apart of the ions times 2 molar, which is a 4. For C, it's 1 times 1, which is 1. And then finally, for potassium sulfite, it's 3 times my 1 molar, which is 3. The highest boiling point then, of course, is our barium chloride, which is letter A. Then what is next is our sodium nitrate with 4, which is letter B. Then it's going to be the potassium sulfite, which is letter D, and then finally letter C. So A, B, B, C, which is choice A. I hope you found this video helpful and what to look out for now with colligative property questions when it comes to the chemistry regents exam. Keep working hard. Good luck. We'll see you next time.